Okay. Shh. Is anybody else like super ready for this weekend? Yeah? Yeah, you're still ready for this weekend? Yeah, this week. Yeah. Yes. This past week has been what? Yeah, I'm coming to your softball game tonight. Where's it at? I'm on baby duty tonight. Gotta watch my babies. I got the kids. Bring them back down to watch you guys. All right, maybe. Shh. I'll get home tonight like 5:30. I gotta make sure I'm ready. Oh, by the time I get them supper and get back down here, game will be over. He'll pitch a no-hitter. Okay, so here's what we need, okay? I know that this class is extremely exciting. I know that you're like, hey, I want to learn about vectors and their components right now. But there is a chance, due to our week and the extreme exhaustion that we're all enduring, that you might feel tired. So somebody's got to be in charge of our stretch break. There has to be, like, if you feel yourself zoning off, you got to raise your hand and say we need to pause, and then we gotta do something crazy and wake up a little bit. So, okay, so Tara's in charge. So when you get too tired, you gotta let us know. And then, so when I was tutoring kids in college in calculus, I remember tutoring. Her name was Carrie. She was a real nice kid. She was a freshman. I was a junior. And when I student taught, I had her daughter, or no, her sister in class. I don't know. Anyway, yeah, she didn't have a daughter. That would be weird. Have a kid when you're 2. Okay. So she, real great person though, but she, it's like we'd be studying calculus, like, it'd be midnight, and I remember one time she fell asleep. I was like, Karen, wake up. It's like, oh, I gotta do something to stay awake. So we'd take laps around the dorm. So we'll take a couple laps around the house. That would be kind of fun, wouldn't it? Okay. All right, we'll do it. Okay, here we go. I'm going to try to move quickly because we're going to cover 2.5 pages of notes in about 30 minutes. Are you asked to graph it? So this is a vector AB. That's how you express a vector, kind of like a ray. That's vector AB. Okay? A vector has an initial point. In this case, the initial point is A. Anybody want to guess what the terminal point is? D, so therefore you express it like that. The magnitude of the vector is the distance that the vector is from its starting point, or the length. And we've talked about length. Remember, we used the term modulus, and that was the absolute value of z. So magnitude of a vector is going to be the absolute value of the vector, which we will identify in a little bit. And now we're going to look at sum of vectors, okay? I just want to draw one more piece in, so this will make sense. So, we're going to call this length A, we're going to call this length B, and there is an angle theta, okay? And we'll get to that in a little bit. We should then change our vector name to something like, say, CD. I don't mean for those A's and B's to be anything similar. So, no. Should I change it to CD? There you go. Okay. So the A and the B have nothing to do with the other pieces. All right, so it says, given the following vector, draw examples of the following. So vectors are interesting in that they have length. They also have direction. And that's important And you have to let go of some of your notions of regular mathematics and start to kind of adopt some of this applied stuff. Vectors are very useful in physics and things like that. So if this is vector v right here, what do you think happens when I have negative v? What do you think it looks like in comparison to the other one? Yeah, it's the same vector, it just goes the opposite direction. And it has the same length, just the opposite direction. What do you think happens if I have 2v? Yeah, it's twice the length. Very good. Very insightful, you guys. You're welcome. You look so smart with the glasses. What's 1/2 v? Half the length. Notice I draw it with the same direction. I just go half the length. And then finally, negative 4v. What is negative 4v? Yeah, so maybe something like that. How's that? Sure. All right. So now we want to sketch examples of the following. Okay, so negative b, a plus b, a minus b, b minus a. And this really worked well for people last year. What? No, we're going to get some vectors later. I don't even know why I put it there. Kind of shooting from the hip. I just pulled these notes up from last year. I don't even know what they said, so I'm just making it up. All right. So if I have a, I'm now going to draw negative a. Everybody agree that that's negative a? What am I going to have for negative b? I could start here. Just go in the opposite direction. Now, here's how I add vectors graphically. If I have a plus b, I'm going to take vector a, so I start here, I end here, and from the ending, I will attach vector b. So watch what happens. Everybody agree that this is vector b? I'm going to take that vector, and I'm going to position it. Hey, don't do that. I'm going to position it, right there. So that sketch is a plus b. So if I start at a, and I end at b when I add it on, so that's a plus b. See how I did that? So the dashed line is what we actually, the dashed line is a plus b. How I generate that is I draw a, and then from the end of a, I attach vector b. Very good. So we'll do another one, like a minus b. So how would I draw a minus b? I would first draw a, and then I would attach to it negative b. So I'm going to grab negative b, and I put it right off of a, and I get a minus b. Yes? How about b minus a? Yeah, so I draw b first, and I attach to the end of b negative a. So if I do that, then that would be b minus a. So you're going to be asked to sketch stuff like that on your homework. What do you think? Can you do that? Okay, so let me help describe. So they really like this first hour, so we'll do it. I got to pause the video. So now you go home on a Friday night. It's like, what should we do? It's like, well, let's play Gens's pushing game. Yeah. All right. No. No. Yeah, I'm sure your Fridays are so much more exciting. Okay, so given we have points x1, y1, and x2, y2 points PQ, we would say that the component form of a vector is as follows. It has a horizontal component that is composed of x sub 2 minus x sub 1, and it has a vertical component, y sub 2 minus y sub 1. This is really simple to do. And yes, we have these kind of funky angle brackets that represents the component of a vector. And it's not very difficult to do, but I'm going to just try to help you understand what it means and what the mathematics is actually doing. So if I draw this, so I've got 1, 2, 3, 4, 5. Okay, so I'm going to draw what? Oh, y sub 2 minus y sub 1. X sub 2 minus... Sorry. Okay, so let's plot the points. We got P is 3, 4 over 3. Up 4. You got Q is 7, 5. Over 7, up 5. That is my vector. Now, let's figure out the component of the vector. The component of the vector is simply going to be, I'm going to subtract my x values. So I have 7 minus 3. That's my horizontal component. And my vertical component will be 5 minus 4. And what do I get? 4, 1. That's the component of the vector. Now watch what happens if I actually plot 4, 1. I'd go over 4, and I go up 1. And if I draw that from the origin, how does that compare to my original vector? It's the same. It's just, as you can see, transformed down to the origin. So that's what it does when you find a component. It just transfers it to the origin. You understand that? So that's what you're doing graphically. Go ahead, find the component form of the second one. Go. Oh, study break. Right after you do this one. Sure, yeah, you don't have to graph it. Nothing. Okay, here we go. Well, what do you want to do? You want to make a lap? You're serious? If you want to make a lap, go quick. See, now the oxygen is in our brain and we're all ready to go. Exactly. All right, the magnitude of a vector. Magnitude of a vector is the distance from the origin. Distance from the origin refers to as the absolute value. So given vector v is equal to the component AB, the absolute value of v is equal to, how do you think we find the distance from the origin? If we wanted to find the distance that C was from D, this length CD, what do you think we would do? A squared plus B squared square root, right? Connected to that stuff we just previously did? Yep. Exactly, just like finding R. So we got the square root of A squared plus B squared. See, everything's connected to the Pythagorean theorem. Find the magnitude of each vector. Let me quick do it. We got the square root of 25 plus 4, square root 29, right? You do the next two. Go. See, everybody who just took their lap is like charged, ready. All those other people, they're just sleepy, tired now. All right, go hit a home run. Good luck. Pitch a no-hitter. Yeah, we got you one. Okay, what do you got for this one? 3, what do you got for this one? Okay, done. Sum and difference of vectors, okay? If you've got u equal to x1, y1, if you've got v equal to x2, y2, and you want to add or subtract the vectors, yep, say we want to take u plus v, what do you think we do with the x values? We add them, so you do x1 plus x2, y1 plus y2. And so that's how you would add vectors. And if it's subtraction, you would just subtract. So you can do plus minus, plus minus, plus minus. Very similar. Well, you saw 7.6 was challenging, right? 7.7, 7a are going to be easier. So given a is 1, 3, and b is 2, negative 2, find the following, 3a. So here's something else that you need to know as well. If you have, say, a constant times, say, v, that's going to be the constant times x sub 2 and the constant times y sub 2. So you can just distribute that constant through to each value. So it says 3a. So 3a is going to be, if a is 1, 3, then I have 3 times 1, 3, which is going to be what? 3, 9. See if you can do the next 3. Go. Oh, she still went out with me. Okay. So for b, you should have 8, negative 8. What'd you get for a plus 2b? 5, negative 1. That is correct. Good job. You're welcome. Okay. Move on. Vectors in terms of I and j. Really, you're not going to use this very much, but your book uses it, so we want to be able to translate back and forth. And really, if a vector is equal to the components ab, then we can write that as ai plus bj. And so, you know, kind of how we had complex numbers like a plus bi, where we had a real part and imaginary part. Remember? Well, you can write it like this, and so you have a horizontal component and a vertical component. So you're not going to use this that often, and it's really just as simple as saying that's the same as that. Okay. And so we'll use it in a little bit. But now we get to, so this is where it gets just a little bit trickier, but this is very important. So this is the crux of what we have to learn today. Horizontal and vertical components of a vector. Go back to your front page. We'll derive this, and this will make perfect sense. Everybody agree that the horizontal component is A? I would like to write that in a way where I could actually calculate A in terms of knowledge of the vector. And I'm going to say that this length right here is the magnitude, which is going to be the absolute value of V. You guys are used to seeing this as R, correct? Did you say Z? No. All right. So sine, cosine, or tangent, which one has to do with the horizontal component, which is A? Sine, cosine, or tangent, which one has to do with A? Tangent and cosine. I'm going to use cosine because I want to work with A, and I want to work with the absolute value of V. So what I have here is I have just a little formula. I'm going to say that the cosine of theta is equal to A over the absolute value of V, or the magnitude of V. Everybody agree? Because I have adjacent over hypotenuse, correct? So I want to solve for the horizontal component. I want to solve for A. And if I multiply both sides by the absolute value of v, I get absolute value of v times the cosine of theta is equal to a. So this part right down here is absolute value of v times the cosine of theta. And that is your horizontal component. You can simply take the magnitude of the vector and multiply it by cosine of the angle, and you get that horizontal component. What do you think the vertical component is going to be? Very good. Magnitude times sine of theta. We could set up the same thing, we'd get that answer. So let's write that down for our sheet. Remember, you have to put together your own sheet of notes for this test. I'm not doing it for you. You're on your own. A is equal to the absolute value of v times the cosine of theta, and b is equal to the absolute value of v times the sine of theta. Those are our horizontal and vertical components of our vectors. The next example says, express the following vectors in terms of I and j. If you're going to express in terms of I and j, what you need is A, the horizontal component, and you need to have B, the vertical component. And if you have those, what's that? Turning you in. All right. See, she starts things. All right, so we have our horizontal component, we have our vertical component, and so we've got to use this to figure it out. Well, it's really not that bad. I know that A is equal to the magnitude times the cosine of the angle. Well, I have the magnitude, right? The magnitude's 3. Now I'm going to take it times the cosine of theta. What's the cosine of 30 degrees? Very good, square root of 3 over 2. So, if I multiply those together, I get 3 roots of 3 over 2. Done and done. Any questions? 2. B is going to be the magnitude times the sine of theta. And the magnitude is 3. The sine of theta, what's the sine of 30 degrees? 1/2. Very good. Which is 3/2. What did the directions say I should write it as? I and j. So therefore, all I do is this. I just go 3 roots of 3 over 2 I plus 3 over 2 j. And that is the same thing as the component that you would normally consider. So these are the same. Don't make it any more difficult than that. Those are the same. I does not mean imaginary. It means interesting. Infamous. Icky. Whatever. You try the next one on your own. Go. 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 We've only got 11 minutes left, so we got to do just a couple problems on the next side. Is that what you got? So you know how to do this. It's a piece of cake. Upside down. Very good. All right. Flip it over. Last part. Now we're going to flip it. We're going to find the magnitude and the direction. Magnitude means the absolute value of the vector, and direction means theta. So if we want to find that stuff, we got to go to our formulas. Well, I know that the absolute value of v is equal to the square root of a squared plus b squared. And so I'm going to have the square root of what? 1 plus 4, which is the square root of 5. Very good. So the magnitude of the vector in this case is the square root of 5. Well, that's pretty simple, right? How do you think we can find the angle? I haven't given you a formula yet. We'll just use what we did before. Tangent theta is equal to b over a from our, well, from much of our other studies. I mean, very common formula. That's slope. It's everything. So, yeah, where's tangent theta? Equal to -2. Very good. So that's what I got to figure out now. Where's tangent theta equal to -2? Am I in the first, second, third, or fourth quadrant? Second, because I'm back 1 and up 2. So I'm going to be in the second quadrant. We're going to solve in degrees. I'm going to take out my calculator, and I'm going to type in First of all, I got to make sure I'm working in degrees. Mode. Yep, there we go. Well, look at your previous problem. They did it in degrees. For complex numbers, you want to work in radians. For your vectors and stuff, they'll just work in degrees. So, let's check it out. I won't try to mislead you on the test, trust me. So, I want to go tangent inverse of 2, and I get 63.43. That's just my reference angle. Which quadrant did we say we're in? So I make an angle over there. How do I find that angle? From 180, I get 116.57 degrees. What do you think of that? All right, now we do the next one. We have, well, it says find the magnitude and the direction. So direction is 116.57 degrees. Magnitude is square root of 5. So I'm going to rewrite this just so you understand it from the previous problem. It's going to be square root of 3 over 3 and negative 1. Does everybody see that those are the same things? So now what we need to do is A, find the magnitude. It's going to be the square root of, what do we give if we square root of 3 over 3? 3 over 9 or 1/3 plus 1. That's the square root of 4/3. Yes? Which is 2 over the square root of 3, which is 2 roots of 3 over 3. I don't know how much time you used to spend doing little problems like that. Rationalize the denominator. Yeah, you guys got it. Okay, 2 roots of 3 over 3. So that's my magnitude. Now I got to find the direction. Well, I got to set this up. Tangent of theta is equal to b, negative 1 over 1 divided by square root of 3 over 3. Multiply by the reciprocal, and I get 3 over square root of 3. That just reduces negative square root of 3, right? Which quadrant am I in, Anna Anderson? How do you know you're in the fourth quadrant? If you graphed it, first value is positive, second value is negative. That puts you in the fourth quadrant. Where is tangent of theta equal to negative square root of 3 in the fourth quadrant? 300! And the winner is Tara Westland. Congratulations. Nothing. That's it. Hey, you guys. We only need to do to finish up 7.7 now, just a couple word problems is what we can do on Monday, then you can have some work time. So you got to get through this homework this weekend because I want to test not next week, but the beginning of the following week. Yeah, like Tuesday the following week. That's when I want to test. And then you will only have one more test by the end of this. Watch your words, young lady. I think you're big time. 2. Dos. That's Spanish for 2. Hey, who's got a birthday coming up for crying out loud? When's your birthday, boss? May 31st? Kelly Sanderson, when is your birthday? Because we want you to bring treats, that's why. When's your birthday? Your birthday's Monday, isn't it? Oh my gosh.